So, when cooling off devices, we use a couple different things. If we're not using like an air conditioner, either, and sometimes with air conditionings and those pumps and refrigerators and stuff, we use a fan to blow over air that cools it down, or sometimes liquids, or we use a bunch of fins to radiate the heat off to the air and stuff around it. But I want to go over two problems and maybe a solution that's more energy efficient in this specific scenario. The problem with passive cooling, with just having a bunch of metal things standing, the air just flows naturally through it, no power or anything, is that there's a limit to how much air you can move through it, and and you have to make it bigger and bigger to cool off faster. And at a certain time, it just can't cool off fast enough, and you have to make it too big and bulky, and heat doesn't move, and the bigger it is, the longer it takes for heat to travel from one place to another place, so it also doesn't scale up as well. When you use a motor to blow air, you start using up some electricity. Also, the design for both of them are a little bit different. When we're talking about a fan moving through something that cools it down, so a fan moves air through many metal seats. These many metal seats do not have some drawbacks, is that they do slow down the air. They add some friction to the air, which actually adds a little bit more heat back into the system, but you need to cool it off. And that means you lose energy. For a system with air flowing through it passively, you want these metal seats also be farther apart than in an active system, because you need the air to flow more easily. I think I know maybe a little bit of a better way of doing it. Oh yes, and one other problem with a fan is that fan blades, as if you imagine a fan, the farther away they are from the center of the device, the faster they spin, because they travel more distance. But also, the closer to the center of the fan, the more closer to every piece of air particles. This means that it doesn't transfer heat evenly, because farther away, it's moving the air faster than closer tip. But at the same time, farther away, where it's moving the air faster to cool off more quickly, it's hitting less air directly. So air farther away, so air near the center of it doesn't get the heat transmitted as fast. If I would think about it along the tip of the blade, it's heat farther away you go from center, the faster the heat is transmitted out, but also radially, but then again it gets slower the farther you away get from the actual blade itself. Also, when you're having air currents are not evenly the same throughout this whole fan system, and you can design better. Stuff is spinning at different speeds, there's different volumes of air it's covering, and so on and so on. So there's another way of moving air, and that is more based on, you can think of it a couple ways: how birds flap their wings, how fish move their tails, how stuff vibrates in the wind like a flag. And if you do it in that, the flag is the opposite way to convert wind into movement. But if you vibrate something along lengthwise, you can move air. Now you have to vibrate in a specific way, has to have a specific shape. But this is a lot better than a fan in evenness, because it's nowhere along the length are you moving air faster or slower, and all of it's the same amount close to the air. And you can make it more compact, because instead of having one fan, you can have many of these blades very close together. And each of these blades can be made out of metal or another material that's a lot more conductive for heat and air, so it can be closer to air and transmit more, like having more little heat exchangers that the fan blowing through. And in fact, the heat exchangers that normally would impart friction in the system now actually moving the air. So there's no friction, so it can move air a lot more efficiently. There's no blockheads. And it's more direct, the whole thing, so you can make it more compact and smaller. This also means you could even have them farther apart to even more increase the air by making it more compact, so you could also have it work better in the passive state, because you don't have to, because you have the area that now you have less of. You can make it more for moving it passively. You would have to design these vibrations to work well, and you can look at fish, how fish move, where they suck, one thing sucks up some fluids, and then it pushes the sucked up fluids in a different direction continuously. These are just some pictures showing the fields where arrows indicate the movement of the water, and the colors indicate the pressure. And you can see another one here where they show from different sides and how the air one mix, but it also mixes air much more evenly, which means that the air filtered also has more even heating, which actually leads to better cooling. And mixing air, the reason why mixing is important cooling is the temperature difference determines the rate of heat transmission. The bigger the temperature difference, the faster transmission is. So if you have any hot spots, it's significantly, if you have any spots that are significantly colder, it actually significantly reduces the speed that heat is transmitted through that. So you want everything to be about the even temperature on the blades and the air to really efficiently transmit heat. Well, thank you very much for listening. Please like and subscribe, and if you have any ideas for future videos, comments, suggestions, please leave in the comment section below. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think can do it. Thank you very much. Goodbye.